Hello, and thank you for taking time to listen and learn more about Syngenta and our commitment to sustainable agriculture. My name is Devine, and I'm a sales representative with Syngenta. My responsibilities are to work with ag retailers across most of the north central and eastern part of the state of Michigan to work with seed and crop protection products. Syngenta is the world's largest company solely focused to agribusiness. Through our inputs of seed care, and crop protection, Syngenta is committed to helping growers meet the challenge of growing more from less, with our purpose and dedication to bringing plant potential to life. A key component of sustainable agriculture is environmental stewardship. At Syngenta, environmental stewardship is a part of our culture. We see it as a key component of sustainable agriculture. But what does that mean? In part, it means we focus to be accountable and responsible throughout the life cycle of every product. And being responsible for the life cycle of every product begins with much of the research that goes into bringing a product to market. A concern that we have with environmental stewardship is resistance management. And part of resistance management is to look at whether it be weeds, insects, or disease, and develop and monitor pest populations, the research that goes into understanding the mechanism of resistance, coordination with government as well as universities, and being an active participant on resistance action committees. These are areas that are extremely important to making sure that the products that we bring to market are sustainable and for long-lasting and profitable agriculture. Thank you, and have a good day.
Hello, I'm Jim Reithel, and I work for the Co-op Elevator. The Co-op Elevator is a grower-owned co-op started in 1915, and we currently have 15 retail and grain receiving locations throughout the thumb of Michigan and one in North Dakota. I am currently the plant manager at the Fairgrove Fertilizer Plant, with the location of most of our plants and growers being located so close to the Saginaw Bay and Lake Huron. We encourage our growers to use environmentally friendly practices. There are many practices, but the one I want to talk about today is site-specific technologies in relationship to fertilizer placement. Our advanced agronomy program starts with satellite imagery of the field we're going to sample. This is a picture of the equipment we use, an ATV and sampler, and we sample based on every 2.5 acres. When the results come back, we put them into mathematical equations to predict how much fertilizer we put on the field. The equations are based off a tri-state, crop removal, and past yield history of each individual field. Once the equations are ran, we place them into variable rate maps. As you can see here, this is the example of a grower that has filter strips alongside a stream that is separating the two halves of the field. The green being the low rates, the red being the high rates. This is an example of the phosphorus recommendation, and this being the nitrogen recommendation. This is an example of the equipment we use in this particular field to spread these two products. This air mass can variable rate spread two different products at the same time, thus reducing our carbon footprint on that acre. It is our job at Co-op Elevator to bring these technologies to our growers so they can make the correct decisions for their operation and the environment. And in closing, I'd like to thank you for your time. And again, I'm Jim Reithel with the Co-op Elevator.
Hello and good day. My name is Jason Bradbury with Crop Production Services out of Breckenridge, Michigan. Crop Production Services is a national retail farm input supply company that provides seed, fertilizer, chemical, and agronomic recommendations to its producers to maximize profitability for them and provide environmental sustainability. I'm here on behalf of Michigan Agri-Business Association to talk to you today about what our industry is doing to try to improve environmental sustainability and rural economic development. One of the main principles that we use to achieve this is the 4 R's of nutrient management. The 4 R's refer to the right fertilizer source, the right rate, the right time, and the right place. We use these principles along with best management practices to optimize the efficiencies of fertilizer and production ag. To further explain, the right source of fertilizer may refer to either naturally available nutrients in the soil and the air or the correct form of fertilizer for optimal plant uptake. The right rate refers to the correct rate of nutrients needed for optimum production based on soil testing, tissue testing, and planned production levels for that crop. The right time is in regards to applying nutrients when most efficient based on crop demand as the crop develops and throughout its growth stages, factoring in environmental conditions and application efficiencies. The right place refers to the application of fertilizer placement in the form of broadcast, in-furrow, side dressing, foliar, whatever is maximum opportunity for plant availability. These principles, together with best management practices, provide the optimum utilization of nutrients that are available to the plant. We use these to promote environmental sustainability and utilization of nutrients in production agriculture, and in turn improve rural economics through improved nutrient management and crop performance while minimizing environmental impact. Again, I want to thank you for your time today and appreciate the opportunity to speak with you on behalf of Michigan Agri-Business Association and Crop Production Services.
My name is Sam Katzer. I'm a district sales manager for a corn and soybean seed company, and I cover northern Michigan. I am currently a member of the 2013 Michigan Agri-Business Association Leadership Program, and as part of this group, I'm creating a video about myself and my role within the industry. I grew up on a small corn and soybean farm in southwest Iowa and went to college at Iowa State University, majoring in agricultural studies with a minor in agronomy, and completed 3 internships in crop scouting, field sales, and agricultural marketing. I've been a district sales manager for 4 years and am currently based in Mount Pleasant, Michigan. What I enjoy about being a DSM is the variety of tasks and roles that we face every day, as well as the great people that we work with. I provide product service information and customer support to retailers and seed sales locations throughout my territory, and work directly with our customers to make recommendations to their farming operations. We begin by collecting information in the fall and traveling around to research plots as well as customers' fields and collecting harvest information and different characteristics of our products so that we can provide detailed recommendations to our customers, not just for yield, but different characteristics of those hybrids and soybean varieties that will make our customers more profitable on their operations. We work with our plant breeders and local agronomy team to make sure that we are getting as detailed of recommendations as possible and having the best products available to offer to our customers. In the spring, we plant these research plots. I travel around and try to plant as many of them with our dealers and our customers as possible to make sure that they are structured correctly and we're getting competitive data against other seed corn and soybean varieties. And we use that information to make those recommendations in the fall with our customers. What I enjoy about this role is that we can't be successful as a company or my territory unless our customers are successful. And so we use that information every day to make sure that we're getting accurate information and providing the best customer service that we possibly can.
Hello, my name is Dale Dosenberry, and I work with the Wilbur-Ellis Company as a technical sales representative in Central Michigan. Today, I would like to introduce to you what it is that I do on a 12-month basis for my potato customers here in Central Michigan.
The production cycle begins each year in the month of August. It begins by taking soil and root samples to be tested for nematodes and verticillium wilt. Potatoes are susceptible to a complex called early die syndrome that is caused by these organisms when present in significant levels. It takes approximately 30 days to get the results back from the lab, so we need to have our samples taken by early September. Once I receive the lab results, I meet with the customers and determine which fields should be fumigated with metam sodium in the fall to help control these organisms and reduce the risk. Fumigation is usually accomplished in October to early November. In the fall, soil fertility samples in 2.5 acre grids are taken to begin the process of determining our nutrition program for the coming season. During the winter months, I review the soil fertility test data. Test results are compiled, variable rate technology application maps are made, and the fertilizer budget and calendar are completed. Once completed, I visit with the customers and review this information. Plans for fertility, insects, disease, and herbicides are made at this time. VRT applications of phosphorus, potassium, and magnesium are made in the early spring before tillage and planting begin. Once the potatoes are planted and they emerge, we begin the summer scouting and petiole sampling program. We view the raising of potato crop as a race to the finish line. A potato growing cycle, once emerged from the ground, is approximately 90 days. Each day and week in a potato growth cycle is dramatic. Thus, we start our weekly petiole sampling and scouting program in mid-June and continue through mid to late August. The petiole samples are sent to an accredited lab and the results are sent back and reviewed each week with the customer. A plan of action, if needed, is determined at this time. During this time frame, we are scouting for insects, disease, and various weeds that may be present in the fields. If necessary, a recommendation for treatment of the pests is given. In late summer, tuber samples are taken to help determine the progress of the crop. We determine if any changes may be needed and how best to finish out the crop to maturity. Harvest begins for storage in mid-September. The growing season should have produced a high-quality, good-yielding potato crop, thus achieving our goal. The satisfaction that I receive from helping my customer maximize his return on investment and seeing the smile on his face is why I do it.
When non-GMO soybeans come into the plant, they first have to go across the scale to be graded and probed and collect the weight from the truckload that comes in. So they first come in across the scale and they're probed via a vacuum suction hose to obtain a sample of the non-GMO beans. They come into the scale house and are ran through the splitter machine to split the sample in half. Once the sample is split into half, we take the grades, which includes moisture, test weight, foreign material sample, and any other off-quality specs for the soybeans. This machine here tests for the moisture of the soybeans themselves and the test weight. Then we also take a non-GMO test, which tests for the Roundup trait and a Liberty Link trait to ensure that the beans are for sure non-GMO certified. And the purity of the non-GMOs need to meet specifications of 99.5%. 99.5% purity. And the non-GMO tests themselves are also taken and done by Michigan Grain Inspection Services.
Hi, I'm Stacey. In the 2 minutes it takes for you to watch this video, you will learn how modern technology makes it easier to manage the inventory of several million bushels of grain. When a truck comes into the elevator, the truck is weighted on the scale and a sample of the grain is taken. This sample is then graded to determine the quality of the grain. These grade factors are then entered on the ticket, and when the truck is weighed out, a ticket is printed showing the weights and grades. The tickets are then imported into the accounting system where the increase in inventory is reflected. Outbound truckloads are handled with the same scale and ticket system, creating a ticket that reduces the inventory when it is imported. Some of the more advanced systems even allow for the selection of the bin that you will be dumping the grain into and taking it out of. When rail cars are loaded, a separate scale system records the weights of the grain being loaded out. The grades can then be entered in the same manner as the inbound loads. The tickets are then imported into the accounting system in the same manner as the truck tickets, also reducing the inventory. As you can see, the use of modern technology allows us to be able to manage grain inventory efficiently, and we can look forward to future advancements to streamline the process even further.
My name is Tiffany Weitzel, and I am a grain buyer at an ethanol plant. Ethanol remains a topic that conjures up a lot of emotion with the general public. Misinformation tends to run rampant while facts get buried. I'm going to share 6 common ethanol myths with you and the real facts. Myth 1. Ethanol producers are dependent on government subsidy. The facts are corn ethanol production is not subsidized. Previously enacted ethanol subsidies expired in 2011, and those subsidies went to blenders and oil companies, not to growers or ethanol producers. Big Oil continues to receive almost $4 billion in taxpayer support despite continued record profits. Myth 2. It takes more energy to produce ethanol than the finished product provides. The fact is, according to the USDA, ethanol is more energy efficient to produce than gasoline. For every 1 BTU of energy used to make ethanol, ethanol provides a 2.6 BTU return. Myth number 3. Using corn for ethanol drives up corn prices and makes food more expensive. The facts are farmers produce more than enough corn to meet both food and fuel needs, and new corn that's grown for ethanol wasn't grown at all prior to the renewable fuel standard. The biggest factors in food costs are transportation costs, including fuel, processing, and packaging. Just 11.6 cents of every dollar in food costs can be attributed to the cost of the raw food itself. Myth 4. Making ethanol uses up corn that should be used for food. The facts are, the corn used to make the ethanol isn't the same corn that you eat, and 1/3 of every bushel of corn used to make ethanol is turned into nutritious animal feed that goes back into the food chain. Myth number 5. Gasoline blended with ethanol will damage your car's engine. The facts are, ethanol is the most extensively tested fuel ever brought to market, and consumers have been using blended ethanol fuels for decades. The EPA approved E15 fuel for use in all cars made since 2001. This is based on more than 6 million miles of testing on 86 engines. NASCAR has run nearly 5 million miles of races on E15 fuel. Myth 6. Growing corn for ethanol damages the environment by causing land to be deforested and increasing use of farm chemicals. Well, the facts are, thanks to modern technology, today's corn growers are producing more corn on less land with fewer resources per bushel than ever before. According to the Fertilizer Institute, in 2010, farmers grew nearly twice as much corn using half as much fertilizer per bushel compared to 1980. The impact of removing the renewable fuel standard on Michigan's economy would be the loss of $260.5 million in economic activity from the lower corn prices, $172.8 million in economic activity from reduced ethanol production, and the loss of 288 jobs. I hope this brief video has provided you with answers to some of the more common misnomers surrounding the ethanol industry.